Y'all, if you weren't in class or if you just want to review, this is what we did today on September 23rd. So we opened class by watching this video, and this video shows a real-world example of how somebody is using what we're doing in class in real life. And this video is basically an archaeologist that finds a skull that's going to help us build the timeline of how humans have evolved over time. And so in the lab, we had a gizmo, and we followed these directions on the gizmo. We took measurements of the skull, and we recorded those numbers into this chart. Then we did some math. We found a ratio. We took our first measurement, we divided it by our second measurement, we multiplied by 100, and we got a ratio. And what we noticed about our ratios was that they got bigger as you go down the chart. And we only did this one, this one, this one, and this one. And we noticed that our ratios got bigger as you go down. And so what scientists have already figured out, and what we proved, is that when the ratio is smaller, that means the skull, where this hole is, this is the spinal opening where the spine meets the skull. If the ratio is smaller, that means the spinal opening is near the back of the skull. And if the ratio is bigger, that means the spinal opening is in the center of the skull. Well, why does that matter? Well, because we know from a bunch of different evidence that if the spinal opening is near the back of the skull, that animal walked on all fours. But if the spinal opening is in the middle of the skull, that animal walked on two legs. And so we took that information and we went down to this question, and I reworded it to make it a little more simple. It might be different on your lab. I asked, how could you use the position of where the spine meets the skull to organize a timeline of oldest to newest species of humans? Well, if we look back at our geological timeline, we see that apes, like chimpanzees, came before humans. So we already know that apes are older than the humans. And so if we look at the position of where the spine meets the skull, and we see that it's slowly but surely going from the back to the center, we can take the skulls and put them in order of, okay, where is the spine? Where is the spinal opening? And which ones are moving towards the center? And what that tells us is that we start with the chimpanzees and the apes all the way in the oldest species, and we slowly work our way towards the humans, right? We see skulls where the oldest ones have the spinal opening near the back, having to do with apes, and the newest ones have the spinal opening in the center of the skull, having to do with humans. So we slowly but surely saw that apes went from walking on four legs to walking on two legs, because we looked at the fossils and we compared them, and we saw it slowly move from the back to the center. And that kind of answers the second question. How does the information in this lab provide evidence for the evolution of humans? And what is evolution? Evolution is just a change in a trait over time. So what's the trait that is changing? Well, there's two. Number one, the spinal opening is moving from the back of the skull to the center. And number two, because we see that the spinal opening is moving from the back of the skull to the center, we know that the animals are changing from walking on four legs to walking on two legs. That's the change in traits over time, and that is the evidence for evolution. And that's what we did today.